let's discuss finding the equation of a plane which is passing through a point and it is perpendicular to a given vector. Okay. Now here, one thing you guys should understand, that perpendicular to a given vector, there can be infinite number of planes. Okay, infinite. For example, let's assume that this is a vector. Okay, you can see that this is the direction of the vector. Now, I can take one plain sheet of paper, cut it perpendicular, it will go inside. Take another one, cut it perpendicular, cut it perpendicular. You can have infinite number of planes like this, isn't it? Now, very important point here is perpendicularity, yes, but that is not unique, isn't it? That's why what we do, we take a given point. That means this is a given vector, the plane is perpendicular to the given vector like this, and also it is passing through a given point. Okay, that means here there could be some point here and the vector is perpendicular and it has to pass to this point. Now this particular plane has a unique solution. Fair enough. That's what we are trying to calculate. We are trying to calculate what is the equation of the plane perpendicular to a given vector and also it is passing through a given point, some given point, whatever it is. Fine. That means in this case, again, we are going to start with the axis. Okay. And we are going to have some plane here. So let's say now this is a plane. Fine. Now first what we'll do, we'll take some arbitrary point in this one. Okay, let always remember the arbitrary point are always given by point P, which is some x, y, z. But there is a given point, isn't it? Say the given point is A. That means here, when you take OA and when you take OP and you can take PA. This, this. Three vectors are there. Now what are the vectors? We'll look into it now. Vector OP is equal to R. Some vector R, but the point is x comma y comma z. Fine. Next, vector OA is equal to vector A. Remember, this is a given vector. Okay, because point A is known, so OA is going to be given vector. Now again, we'll use the triangle law. If you use triangle law, we can calculate PA, isn't it? That means in this case, what we are going to have, we can write by triangle law, OA is equal to OP plus PA. What is PA now? PA is equal to A minus R. This is going to be PA vector. AP vector becomes what? AP vector. This is going to become R minus A, correct? Minus of A minus A, R minus A. This is vector AP. Okay, well and good. See, the next thing is you have a plane, isn't it? Say the plane is given by some value n. N is the equation or n is the vector of the plane. Okay, this is the vector of the plane. Now, what we are trying to do, we are trying to find the equation of this one, isn't it? For this, what we are going to do, remember r dot n cap is equal to d. Remember that particular formula? We are going to apply the same thing here. Whereas there is one particular relation which is very, very important. Remember, on the plane, okay, on the plane, say we are going to take one perpendicular like this. Fine. See, we have taken vector of the plane is n vector, correct? Now, vector of the plane or the plane vector is nothing but the normal what we have. That means here, suppose if say this is vector n, some value vector n, then we can say that vector AP dot n is equal to 0. But what is AP? R minus A, isn't it? So what we are going to get is R minus A dot vector n is equal to 0. This becomes the equation of a plane which is passing through the point A and perpendicular to the plane. Fair enough, this is the vector form. Now we'll look at the same thing in the Cartesian form. For the Cartesian form, what will take vector A is equal to x1 I cap plus y1 j cap plus z1 k cap. Now vector R is what? xi plus yj plus zk, isn't it? Now vector n will, let's call this as capital letter A into I plus capital letter into j plus capital letter C into k. AI plus bj plus ck. Okay. What is the formula, whatever we have learned just now? R minus A dot n is equal to 0. Correct? So now what do we do? Substitute. See, R is xi plus yj plus zk and A is x1i plus y1j plus z1k. So R minus A, if you take, you are going to get x minus x1 into I cap, correct? Plus y minus y1 into j cap plus z minus z1 into k cap into k cap dot ai plus bj plus ck is equal to 0. See, once you apply this one, I and I gets multiplied, j and j, then k and k, isn't it? So what we are going to get is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. So this gives the equation of the equation of the plane in the Cartesian form. And this is the equation of the plane in the vector form. Fair enough. These are the two equations in the vector and the Cartesian form.